Well, greetings all. Hey, here are the plans today. If I was there, I'd answer any questions over section 7.2, but what I did for you is I have the answers to those on the next slide. So I have these answers so that you could look at it and see how you did. Then you come in and fill any questions. If you have your class notes in front of you, on 1 through 5 I have a skill check for you. That is a beautiful skill check before we take this quiz. So make sure that you sit down and go through that skill check and make sure you understand that. If you're successful on that skill check, you should be very successful on the quiz. And then what I need to do with you today after the quiz is I need to cover the antiderivative of quantities using the U substitution again, but I need to review with you and show you how we find it for the E function and then the natural log function. The assignment will be a worksheet. You can pause, if you're listening to this video at some point, you can pause it. There should be the answers for that worksheet that I gave you from section 7.2. So there's the answers through the first 11, there's the answers through the other ones. So at some point you can look at those, circle anything, see if you need to have any questions, come in and I'll get those straightened out. This looks like an old skill check from 2 times ago. I left that on there in case you have that sheet in front of you still, and you did that for extra review. So there's from 2 times ago, and here's the answers for today's skill check. So make sure that you understand where I get those answers from. So take some time and do that before we quiz, and you're going to be very successful. But here goes the main meat of the day. I need to review with you the E function. And what I'm going to do is, just like when we started our antiderivatives, I'm going to find the derivative and then write a true statement, hoping that you kind of start catching a pattern. And then I'm going to clean that pattern up. So here goes. I'm going to give you f of x equal e to the 6x, and I'm going to find the derivative of this. Trip down memory lane. The derivative of an E function is what you see is what you get, so e to the 6x, times the derivative of the exponent. And the derivative of 6x is 6. So this derivative is 6e to the 6x. Here comes a true statement then. The antiderivative of 6e to the 6x dx is e to the 6x plus c. Remember, all this says is I found the derivative of something. That's that notation with that dx. I found the derivative of something. I got 6e to the 6x. What was that something I found the derivative of? Right there. So pretty soon I'm going to give you that. You have to give me that. And it's not as easy as what you're thinking. It's not always just get rid of that. You wish it was that easy. Here goes my second one. The derivative of e to the 2x squared is, what you see is what you get, e to the 2x squared times the derivative of 2x squared, which is 4x. So here comes my true statement. The antiderivative of 4x e to the 2x squared dx is, e to the 2x squared plus c. Okay? And then once again, it's not always that easy. That's going to be a piece of my answer, but it's not always just get rid of that. Here goes the next one. Like I said, these aren't on your worksheet. These are just some I made up. When I find this derivative, it's going to be what you see is what you get, so e to the 1 over x. But I need to go find the derivative of 1 over x. So I'm going to come over here. I'm going to think of this as e to the x to the negative 1, whose derivative is negative 1 over x squared, and I'm going to bring that back. Here's my true statement then. The antiderivative of negative 1 over x squared e to the 1 over x dx is e to the 1 over x plus c. So what am I going to do to you pretty quick? Take you from there, and you got to give me that. Last one. The derivative of this will be, once again, e to the square root of x. And then I have to come over here and find the derivative of the square root of x. So I'm going to think of that as x to the 1/2. So I got 1/2 x to the negative 1/2, which is 1 over 2 radical x. So that's what I'm going to bring back. I jammed it in there a little bit. So here's my true statement. The antiderivative of 1 over 2 radical x e to the radical x dx is simply e to the square root of x plus c. I do want to point out one thing though. When we do the derivative, notice it kind of gets messier. When we do the antiderivative, notice it really kind of gets cleaner. There's not as much there. But once you look at your examples, I'm going to kind of show you how we'll go through that using use substitution. The easy ones you could look at and know the answers. But the harder ones, you're going to have to go through the steps. So make sure that you know these steps. So the rule for the antiderivative of e to the u is e to the u plus c. Remember, the derivative of e to the u is e to the u times its exponent derivative. Same thing there. Our key is, though, is I need to let u equal my exponent. So here goes. Well, I got you a little confused. I would like to find the derivative, or the antiderivative, of e to the 3x. Here's going to be my steps. Since there's a single e involved, there's just one e in here, I'm going to let u equal whatever the exponent is. So in this case, I'm going to let u equal that exponent of 3x. That makes du 3 dx. So here's what I got to do. I got to see a 3 and a dx. So just like we did last time, I'm going to put a 3 there, which means I got to put a 1/3 out there. This now becomes 1/3. The antiderivative of this 3 dx becomes du. So I have e to the u du. I need that 1/3 out there to make sure my derivative comes out right. But that 3 dx becomes du. E to the 3x becomes e to the u. But the antiderivative of e to the u is e to the u, so this really becomes 1/3 e to the u plus c. So my final answer, 1/3 e, u happens to be 3x plus c. There's my answer to that one. If I were to check it real fast and find this derivative, I'd have 1/3 e to the 3x, what you see is what you get, times the derivative of the exponent. Those cancel out, getting me right back to what I started with. But there's the game I got to play. Use substitution once again. So here goes. On my second one, I'm going to let u equal 5x plus 6. That makes du 5 dx. So I need to see a 5 and a dx. I do if I put a 5 right there. That means I have to offset it with a 1/5. That means this becomes 1/5 times the antiderivative of 5 dx is my du. E to the 5x plus 6 becomes e to the u. My answer now becomes 1/5 e to the u plus c. Soon you'll be skipping this step. My answer then, 1/5 e to the 5x plus 6 plus c. If you found that derivative, it'd be 1/5 e to the 5x plus 6 times 5. That would cancel that out, leaving you what we started with. But the key is letting your exponent be that. Here goes your number 3. I've got 2x e to the x squared minus 3 dx. So I'm going to let u equal the exponent, x squared minus 3. That means du is 2x dx. Now let me think through this. I need to see a 2x dx, and I do right there. So I don't have to do anything extra this time. When I rewrite this then, I have the antiderivative of 2x dx becomes my du. My e to the x squared minus 3 becomes e to the u. The antiderivative of e to the u is e to the u plus c. So my final answer, e to the x squared minus 3 plus c. But Mr. Harris, where did that 2x go? That would show up if I asked you to find this derivative. If I asked you to find this derivative, it'd be what you see is what you get. Remember, the derivative of c is 0, times the derivative of your exponent, 2x. There it just showed back up. So here goes your number 4. I'm going to let u equal the exponent, because there's just a single e in there. So my u is going to be x cubed, making my du 3x squared dx. So this time I got a little work. I need to see a 3x squared dx. There's 2 ways to do this. You pick whichever way you see the best. I could turn a 4 into a 1 by multiplying it by 1/4. I need a 3 though. So I'm going to multiply this by 3/4, which means I need a 4/3 out there. That's one way. That's one way. Here's the other way, and then you pick the way you like the best. You have the power, anytime there's a constant, you can just get that out of the way. Now you need a 3 right there, so put a 3, but put a 1/3 out there. And 1/3 times 4 is 4/3. So all of this now becomes this. I have 4/3 times the antiderivative of 3x squared dx becomes my du. E to the x cubed becomes e to the u. This antiderivative becomes 4/3 e to the u plus c, which becomes 4/3 e to the x cubed plus c. That's why I didn't want you to try to do too much in your head with the u. Like the early ones are easy. But like on this one, I needed to see a 3x squared, so you have to work your magic and turn that 4x squared into a 3x squared. What I do a lot of times, I multiply it by 1/4 to turn it to a 1, and then a 3 to get the 3, so I know I got a 3/4 there and a 4/3 out front. So whichever way you like to do, find your method and we'll roll with it. Here's your number 5. There's a quantity here, but there's still a single e. When there's a single e, this is the method that you use. I'm going to let u equal x squared plus x. That's going to make my du 2x plus 1 dx. So I need to see a 2x plus 1 dx. And lo and behold, I do. So this becomes the antiderivative of the 2x plus 1 dx becomes du. E to the x squared plus x becomes e to the u. I didn't need to do any extra work this time. This answer becomes e to the u plus c. So my final answer, e to the x squared plus x plus c. So there's what we've got so far. It looks like I've got just a couple more e's, and then I'm going to move on to the natural logs. So here goes my next one. There's a single e involved. There's no quantity with an e. There's a single e, so I'm going to let u equal 1/2 x squared. That makes du equal to x dx. So I need to see a x dx. And you got 2 ways to do this. One way, I need to turn this 3x into a 1x, so I could multiply by a 1/3, which means there's a 3 out here. That's one way. The other way is you could move this constant out here. Doesn't change anything. So no matter which way you do it though, guys, there's going to be a 3 out here. So this now becomes 3 times the antiderivative of this x dx becomes my du. The e to the 1/2 x squared becomes e to the u. Its antiderivative is 3e to the u plus c. My answer, 3e to the 1/2 x squared plus c. You'll know to use that method when there's just a single e involved with a bunch of other stuff. So there's what I got so far. That takes me through your number 6, it looks like. Now I'm going to change the game just a little bit on number 7. So here's your number 7. I'm going to tie in what we did last time. Remember last time when we dealt with the quantity. Because check this out. I have an e here, and I also have an e there. So I got 2 e's to worry about this time. But notice this even more. I have a quantity right here. The quantity trumps a single e. So since I have 2 e's in there, I need to look for the one within a quantity. So now this is back to what you did last time. There just happens to be a u involved, and a u, and an x, and a e, there we go. So I'm going to let u equal 1 minus e to the x. That makes my du, the derivative of 1 is nothing. The derivative of e to the negative e to the x is negative e to the x dx. So I need to see a negative e to the x dx. And I would if there's a negative right there. Well, since I put a negative there, I also got to put it there. Now when I rewrite this, here's what I got. I got the antiderivative of this negative e to the x dx becomes du. But notice I got the square root of 1 minus e to the x, so this really becomes the square root of u. Because u is 1 minus e to the x. So this really becomes negative u to the 1/2 du. Now we're back to what we did a couple of classes ago. Add 1 to the power, so that becomes a 3/2. Multiply by the reciprocal, and I've got a negative out front. So plus c, my ending answer, negative 2/3, parenthesis u, which happens to be 1 minus e to the x to the 3/2 plus c. Now remember, if you did the chain rule, the 3/2 would come down and multiply with the 2/3 and cancel out. So I would have negative 1 minus e to the x to the 1/2 times the derivative of whatever's inside, and the derivative of whatever's inside happens to be negative e to the x. 2 negatives make a positive, so I'm back to where I started. So it checks. There's just a few steps there. But what I had to worry about there, guys, is I had 2 e's involved, and I had the quantity. So I had to let, like we did last time, I had to let that be my quantity. Hey, so I'm going to switch gears on you now. I know we may have a little confusion, but I need to switch gears on you now and show you the natural log, how we handle that. So this is not on your class examples. I'm going to kind of take you for a trip down memory lane and show you what I got. But I'm going to do what we did earlier. I'm going to find the derivative, and then I'm going to write a true statement. But here's where I got to go. Remember, or at least I hope you remember, to find the derivative of a natural log function, it's the derivative of what you see over what you see. So the derivative of the natural log of x, don't get caught up with that notation. Our book decided to put them all in absolute values this time. So this derivative is going to be the derivative of what you see, 1, over what you see, x. So here's a true statement. The antiderivative of 1 over x dx is the natural log of x plus c. Of course, here comes the hard part. You're going to have to recognize when it turns into a natural log. Okay? But I do want to point this out. Notice that down here on the bottom, there's an x to the first. Whenever I get a quantity to the first in the denominator, the natural log is going to show up. And here's how come. If I gave you 1 over x and you decided to call that x to the negative 1, if you added 1 to this power, you're going to get a 0. If you try to multiply by the reciprocal of 0, that would be 1 over 0. You're trying to multiply by a number that doesn't exist. So that's why it turns to a natural log. But just to show you, this derivative, natural log of 2x minus 5, is the derivative of what you see over what you see. So here comes my true statement. The antiderivative of 2 over 2x minus 5 dx is the natural log of 2x minus 5 plus c. Once again, 2x minus 5 is to the first power. So you're going to be going from there to there. And then 2 more, and then I'm going to get back to your example sheet. So this derivative, the derivative of what you see, 2x plus 3, over what you see, x squared plus 3x plus 1. Here comes my true statement, the antiderivative of 2x plus 3 over x squared plus 3x plus 1 dx is the natural log of x squared plus 3x plus 1, and I'm jamming myself on room, plus c. Okay. I'm not going to worry about that one since I kind of jammed myself on room. But what I will do is I'll get back to your examples on your sheet. But here comes the main rule. If you have something, if you have a quantity in the denominator that's to the first power, whether it's a quantity or a single variable, it's going to turn into a natural log function. The goal on this is to use u substitution and make it look like 1 over u. So here goes your first example. I would like to find the antiderivative of 4 over x. Now this one's going to kind of be an easy one. So here's going to be my steps. I'm going to let u equal whatever's in your denominator. And why am I doing that? Because it's to the first power. So my u is going to be x. My du is going to be 1 dx. So I need to see a 1 dx, but I got a 4. Once again, you have 2 choices. I need to turn that 4 to a 1. One choice, multiply by 1/4 there, which means I'm going to multiply by a 4 out there. That's choice number 1. The other choice I got, since that's a constant, you could move it out here and replace it with the 1. That part doesn't matter. But this becomes 4 times the antiderivative of 1 over u, du. Whenever a 1 over u shows up, that's the natural log. So this becomes 4 times the natural log of u, but u happens to be x, and I'm going to put it in absolute value like our book did, plus c. So once again, my denominator was to the first power. That's my symbol that I'm going to have a natural log. So your number 9 is going to be just like it. I'm going to think of this as I'm going to let u equal x. Du then is 1 dx. So I need to see a 1. So I got to turn this 10 to a 1 by multiplying by 1/10 and putting a 10 out there, or moving this 10 out there and putting a 1 there. So this becomes 10 times the antiderivative of 1 over u du. Whenever that shows up, it's a natural log. So here's my answer. 10 times the natural log of u, which happens to be the x, plus c. Easy to check. The derivative of natural log of x is 1 over x. I'm going to multiply it by 10, and then I'm back to where I started. After you do a few of these, they really get kind of easy. Here's my next one, another easy one, your number 10. Please notice, though, that the denominator is to the first power. This 3x plus 1 is to the first power. If it's to the first, it's going to be a natural log. So here goes. I'm going to let u equal 3x plus 1. That means du is going to be a 3 dx. I need to see a 3 dx, and I do. So I don't have any extra work to do. This becomes the antiderivative of the 3x plus 1 is my u. My 3 dx is my 1 du. That tells me this answer is the natural log of the absolute value of 3x plus 1 plus c. If I checked it real fast, the derivative of what you see over what you see gets me right back to where I was. Here's your number 11. I'm going to let u equal 2x minus 1. That means du is 2 dx. So I need to see a 2 dx. So to do that, I need to put a 2 right here. That means I need to offset it with a 1/2. So now when I rewrite this, it becomes 1/2, the antiderivative of the 2 dx becomes my du. I have a 1 over 2x minus 1 is u. That's my green light that it's a natural log. So my answer, 1/2, the natural log of absolute value of 2x minus 1 plus c. And then I got it. I just have a few more to hit with you. But the key is using the u to know what to change. Here's your number 12. Once again, I know that the denominator is to the first power, so that's my q, a natural log's coming, and I'm going to let u equal x squared plus 1. du is going to be 2x dx. So I need to see a 2x dx. So I need to turn this 6 into a 2. So remember, you got two options. To turn a 6 into a 2, I can multiply by 1/3, which means I'm going to put a 3 out there. That's one option. Your other option is, since this is a constant, you can move it out here, put a 2 there, and a 1/2 there. Either which way, you're going to have a 3 out there. So this becomes 3 times the antiderivative of 2x dx is my du. 1 over u, x squared plus 1 is u. That's my green light. That is the natural log. So 3 times the natural log of x squared plus 1 in parentheses plus c. Hey, the reason I put this one in parentheses, x squared plus 1 is always positive anyway. If you went ahead and put it in absolute value, more power to you. It's not going to change anything. And then just to kind of keep clicking through them, I'm not too far from done, to be truthful. My quantity in the denominator is to the first power, and my x cubed is bigger than my x squared anyway. So my u is going to be 3 minus x cubed. My du is going to be negative 3x squared dx. So I need to see a negative 3x squared. So I'm going to put a negative 3 right there, and I'm going to offset it with a negative 1/3. Remember, we do all of that to make our ending answer come out to where I could check it. So this now becomes negative 1/3 times the antiderivative of negative 3x squared dx is my du. This part becomes 1 over u. U's to the first, that's my green light, it's a natural log. Here's my answer. Negative 1/3 times the natural log of 3 minus x cubed, absolute valued, plus c. And if you check it, the derivative of what you see over what you see times that negative 1/3 out there makes this go away and leaves you with that x squared that you started with. So it checks. But there's my answer. Here comes your number 14. Looks harder, but it's not. My u is going to be this big old quantity that's to the first power. So u is going to be x cubed plus 3x squared plus 9x plus 1. My du is going to be 3x squared plus 6x plus 9 dx. So I need to see a 3x squared plus 6x plus 9, and I would if I tripled that. Trust me, I will show you what happens, not today, if it's not that easy. So there's going to be a 1/3 out there. So this becomes 1/3. All of this dx becomes du, and I've got 1 over u with the rest of it. Answer, 1/3 times the natural log of x cubed plus 3x squared plus 9x plus 1 plus c. And then we got it. Okay. I'm going to change the game just a little bit on number 15 and 16. Notice number 15 just flat out looks ugly. It's not as bad as it seems, though. You just got to decide what to let your u equal. I got to decide what to let my u equal. So look through and ask yourself, if I found the derivative of this, could I get anywhere close to the other? So if I let this be my u, don't write this down. This is going to be 6x plus e to the x, whose derivative is 6 plus e to the x. Nowhere close to that. So this is a quantity one because I have two e's involved. I'm kind of switch gears on you here. So my u is going to be 3x squared plus e to the x. That's going to make my du 6x plus e to the x dx. So I need to see a 6x plus e to the x, and I do. So happy birthday to me. This becomes the antiderivative of, all of this becomes du. This part becomes u to the 1/2. I totally switch gears on you because you kind of get in such a habit. Now go find this antiderivative, add 1 to the power, multiply by the reciprocal, 2/3, plus c. So my answer, 2/3, 3x squared plus e to the x to the 3/2 plus c, and then we got it. Okay. Hey, so I switched gears on you a little bit. I'm going to switch gears on you a little bit on number 16 also, and then I will be through with my video. Finally, Mr. Harris. So here's my number 16. Not that it's any harder, but I threw this one in to mess with your minds. Notice that I said it's going to be a natural log if your power in the denominator is to the first. Well, that is to the first, but also check out your numerator. It is 2. So we're still going to do like we always have done. I'm going to simplify this into the antiderivative of x divided by x is 1 plus 5 over x dx. Now don't get caught up in the u substitution. This is really the antiderivative of 1 plus the antiderivative of 5 over x. Now go find each antiderivative. Well, the antiderivative of 1 is just going to be x plus the antiderivative of 5 over x. Here's u substitution if you don't recognize it. U is going to be x. Du is 1 dx, so I would have my dx there. This really becomes the antiderivative of 1 over u if you get rid of that 1. So let me backtrack just a little bit. I need to see a 1 dx, and I would if I change that 5 to a 1. So I'm going to move that 5 out here. That's going to make this a 1. That tells me I have a natural log. So this becomes 5 times the natural log of x plus c. Hey, so reduce that thing first and then find each antiderivative. Okay. Hey, at the very bottom of your class example sheet, I don't have it on here, but it says, you know to use the ln when the quantity in the denominator is, whenever the quantity in the denominator is to the first power, that's your cue that it's going to be a natural log. So that takes care of my video. Good luck with the assignment. If I thought about it, I will post the answers on Moodle. If I didn't think about it, I'll get questions answered when I get back. Good luck.